The included angle. All right, that is more or less the angle of the drill bit. So general purpose. Yes, general purpose is 118 degrees. True story. If I could draw an actual aircraft nut, that part's not important. All right. And I put two of them right next to each other. This area right here is 118 degrees. So, in a pinch, you can use two large nuts. All right. If you were that into it. Okay, high strength. High strength steel is flatter at 140 degrees. And, this allows more of the drill to make contact, especially when starting.
Would that also allow you to put more force behind it without damaging the drill bit?
Sure. It sounds logical, yeah, I like that. This allows more of the drill to make contact, where was I? Especially when starting. E-S-P-E-C-I-A, especially when starting. All right, drills for softer material.
Hope there's not a lot more notes because I'm on the last page of my notebook.
Just tell me, I'll be done. I'll just stop writing too. Have more of a point. Have more of a point. Where that would be 90 degrees. And that is allows less of cutting lips to make contact. Make contact. There we go. All right, so this would be point 2 because 1 was included angle because we're talking about the drill point. Now we have the cutting lips. And that is also the cutting edges.
Why would you want less for 90 degrees? Why would you want less?
You have to kind of be careful when you're doing soft material in that the drill bit actually starts to grab and will pull itself in. And then when it pulls itself in, it gets to the back and it blows out the back. Which is why when you're drilling plexiglass, you have to do two things. And Larry will do more with plexiglass, but you always back it up and you have to go through the plexi into something else. And you actually get rid of the cutting lips. You grind them down so they're flat. And they can't actually get a grip on anything. So it just burns its way through. Cutting lips, okay, cutting edges, let me see. How was it for that? The relief angle. Let me see if I can do a picture here, relief angle. Got that, we got cutting lips, okay, there we go. Cutting edges that extend from the center of the drill to the outer diameter. One of the things I'm looking for when you do sharpen your drill bit is it's called facets. And a facet, like if you consider like a diamond ring or something, all the little angles, that's a facet. So there is not a bunch of different angles built into this. It is one smooth piece across. So if I hold it up in the light and I can see 27 different angles, Like, no, that's not right. Actually, or even 2 or 3 is not right. Let me see. Okay, that's the best one I think I can come up with here. Let's try this. The relief angle, this right here has to be the highest point of the drill bit. Because if this right here out towards the middle is the highest point, then what happens?
Oblong?
Let me see. So, all right. If this happened to be the highest point, and this is the highest point, so in other words, it starts sloping down this way, and it starts sloping down that way. So when I put the drill in the drill press and I go to start cutting a piece of metal, and this is where it starts touching first, what's going to happen? What's that?
It's just gonna ride on it.
This is going to, it'll get very, you can melt a hole, but where's your cutting lips? Over here. So if your cutting lips are down low, down here, and then it goes up to this point and then back down, and so it's just rubbing out in the middle, then are you going to cut anything with this section right here? I hope you guys can see that, because it really makes it, this is like huge when you're doing that project. I'll be like, well, you're like, I don't understand why it doesn't cut. And I'll look at it, and the drill bit's going like cutting lip, up to the middle, then back down. I'm like, when you put it in, you can see that it'll even turn blue right here if you want it to. You know, press hard enough, because that's where it's rubbing against. So you're not going to cut it. So if you can see that, hopefully, I forget what button. Jeez, there we go. This right here is the high side, right? This is the tallest, and then from there it slowly goes down to the heel right here. Yeah? Okay. So that angle then that is formed right there is what I call the relief angle. And that's kind of what that's depicting, but in a really crappy way. I don't know what else we got now.
The angle from the cutting lips to the heel.
Yeah, it's actually this angle that's, because these are flat right here. Oops. So that actually angles down like that. And so it's that angle right there. It's not as flat as they would make you believe right there. All right, relief angle is relief angle. I'm almost out of paper too. So yeah, we're almost done. The section of the land that is ground down, leaving the lip higher. So the section of the land that is ground down, leaving the lip higher. Oops, leaving the lip or cutting edge higher. So without the relief, the entire land would rub on the work and overheat the drill. Like that. Without the relief, the entire land would rub on the work and overheat the drill. And the work. By the way, what's the hottest you can get your aluminum?
I don't know.
About 700 degrees, is it? 680, 700?
1 million is over.
Yeah, how high can you get, say, 2024 T3 without affecting its properties?
I don't know, about 300 degrees.
Well, you guys are
Melts at 1200, right?
boiling water.
212?
Yeah,
Oh,
yeah.
that's not very warm.
I think it says in 4313 or somewhere. Not supposed to go over boiling.
So even using the grinding disc out there,
You're not,
If you put it on there for too long, it'll start affecting it?
yeah.
Wow.
Yeah, if you get it that hot, absolutely. Although I worked with one guy, very clever guy, I'll give him that. A very, very good mechanic. And so, what is O? 2024 O?
Untreated.
He goes, I thought he was done with this stuff too.
Non-structural.
Okay, non-structural.
Non-rigid.
When do I want to use? When do I want to use O material?
It's too flimsy.
When do I want to use it?
You wanna
When you
shape
make
your
it-
metal, form it.
And form. Yeah.
Forming, shaping. Okay, so it's non-structural, or for forming, and then it could be structural later. I'll do this. So he was making a nose bowl or something for an Araka or something, very low horsepower, and so that's a non-structural issue. It's just a cowling. It's no structure. It's just aesthetics, but it's a complex curve. We didn't have any O, and or didn't have what we wanted, and so he had read some article. It was really cool. He goes, "Watch this," and so he takes a Sharpie, and he just scribbles on it with Sharpie, and then he lights the torch, the rosebud, on the torch. And he just starts heating this thing up, heating it up, and suddenly the Sharpie disappears. He goes, "It's done," and let it cool, and it was basically annealed. It was O at that point. So
Weird.
now, is that acceptable? So that's going to cause probably later on in life corrosion issues and stuff like that.
How does that work?
Just like putting it in the oven, right?
It's just annealing it. Yeah, you're just reheat treating it, or you're kind of losing the heat treat.
Isn't that structural design?
Now, along the lines of this class that we're going to get into, is I did hear a story about Boeing had done this. They had to make a nose cone on one of the bigger Boeings, and so there was some sort of damage to it. So that, they have giant autoclaves, and they do their own heat treating and all this kind of stuff there. They make parts, and so they had formed this whole tail cone complex curve, and they had finished it. They had put it on, and I forget whatever reason why, but they had called for an eddy current on this. And an eddy current, and you'll see, eddy current is used, it puts little eddies in, and it has a probe that will detect if the eddies are disturbed, and it will see if there's a crack. Well, eddy current is also used because it works off of, don't shoot me because it's only day one, off of the Z impedance. So it works off impedance and inductive reactance. And so, I thought we were done. Back to electricity. And it works off that. And so if you take a eddy current with a known block, and you put the eddy current on and you set it up on a known block, and then you take that same eddy current and touch it on the suspect, the impedance has to be exactly the same. And if it's not, something's wrong. And so they had done this, and it's like it didn't match the specimen. They forgot to heat treat it. And it changes the eddy current. So
That's a big deal.
yeah, you kind of want your airplanes to be heat treated. So where was I here? Relief angle.
Relief angle without the relief.
Without the relief, the tire land rib on the work no heat the drill. Item 2. Let me see, ranges from 8 to 24 degrees. That's an angle, not a temperature. Like, why so cold? Okay, higher angle. If you have a higher angle, potential, I could say corners of the lip will break or chip, because you've got that I should have brought a big drill bit, I knew it. So you've got the cutting edge right there, and if you have it really the angle coming way down, well, there's nothing backing up the lips, and so they have the potential to break. But if you flatten it too much, then you get more rubbing. So so there's this happy medium. Lower angles. Lower angle requires more pressure. More pressure and will cause heat. And heat is bad because we should not be heating up our heat-treated aluminum past. Yeah, I think that's right out of 4313. This sounds like something I added. And inverted angle just means heat. With no cutting. In other words, the actual cutting lip is down below the rest of the drill bit. It kind of starts high and goes down low to the cutting angle. Well, that's just not going to work. All right, chisel edge. I don't know, there's not much you can say about the chisel edge. It just is what it is. Well, hang on. Chisel edge angle is what I wrote. That's not an angle you're going to mess with too much.
Wouldn't that just be the cutting lip angle?
Yes and no. I'll show you. So it's this angle right here, between here and here. I'm sure I have a slide for it. So there we go. We had the lip relief angle, which we just talked about. Chisel edge. There we go. Chisel edge. We talked about that. Chisel edge does not cut. It penetrates, displacing the workplace material. Chisel edge consumes 60 to 70% of the thrust required. So the bigger it is, the more you're going to be putting on there. I don't have a... So the chisel edge angle then is, like I said, from here to here. Good luck changing that. It's going to be very difficult. The angle between... Angle between the chisel edge What happens to the chisel edge as the drill gets shorter?
It's
It's
wider.
bigger.
Okay, chisel edge and the cutting lip. All right, let's see. That brings us to drilling speeds. Hey, let's go back up here and go here. There. All right, so you got your thing here, right? Okay. Your paper. This right here in the little blue book and a lot of books, I forget what they call it. It's just ridiculous. I forget what that is, but it's like, no, I don't think so. Let me see. There we go. Well, that would be better if it was readable, wouldn't it? Well, it is right there. So, yeah, the lip clearance angle, no, that is not. I don't know what the hell they're trying to say right there. That makes no sense to what that is, so ignore that. So we got the heel angle, or what did we call it earlier? The relief angle. I called this the relief angle. So we have the body, the shank, the flute, the land, and then next to the land is the margin. I do like this right here, the lip clearance angle. That makes sense to me. The lip clearance angle right there. And then you have the cutting edges right there and there. I don't worry about this heel angle. It's almost the same to me as what they're trying to show with the lip clearance angle. I'm going to rotate it. Hang on, let's go this one. I like this one better. You can see that one. So the margin, the land, chisel edge, which is also the web or core thickness, is the same thing. You have your cutting lip and a flute. Tell me when you're done. Got it? All right, let's go back. Let me see. It'd be easier if I go this. I know I should. You want me to rotate it? Well, I gotta make it smaller. Give me 1 second. Well, look at that. That's just being fancy. This, I don't even, do I have that on there? I,
Just leave it blank.
yeah, it's not really, to me, the lip clearance angle right there at all. I don't know what they're depicting. That makes no sense to me. It's this lip angle right here is what I'm more interested in. Oh, that's not the lip. That's the included angle right here. So lip angle, I would call it the included angle. 59 degrees. It's 118. So we called it the included angle. This heel angle, I call that, well, it's more depictive of the relief angle, if you ask me.
Could you call that lip clearance the chisel edge angle?
I would, except that it doesn't line up with this chisel edge. If it did, I would call it that. So I don't know what the heck they're saying. I mean, this point right here is nothing to me.
Well, just change it.
Uh,
Draw your line.
Make her own line. Make it
Your
count.
own line.
make it, yeah. So I don't worry about everything on there. It's not that important. Okay, can I move on? All right. Let me see. I'll take a look at this. I just threw this in here for fun, I think. Let me see. Do I talk about it? Oh, I get into this a little bit. I gotta circle back around. Feeds. All right. See a vidya?
I like that. Just 20 minutes.
So, yeah,
Long time.
How much time is it?
Our new EV rental fleet is the absolute goat, guys. Speaking of goats.
So if you do all that drilling in metal,
Forgot. I gotta stop the recording because YouTube will flag it.